Okay, so I think we're going to get started here. Took a few minutes to transition, and the aim is to finish by 5 p.m. But welcome once again, this time to the panel discussion for the summer school for the week. My name is David Miller. I'm actually a professor in the physics department and engaged in a whole host of different activities, some of which touch upon a lot of the work that's actually been discussed here. And so it's been really fun so far, and really excited to hear from our panel today. So I think we'll start out with a very brief introduction. I could do it, but I think it's better if you guys run through just who you are, where you're from. Obviously, some of you have introduced yourselves to the audience already, so we can keep it quite brief. And then we've collected questions from the attendees of the summer school. Many of you have contributed, and I kind of categorize them into sort of three broad topics of, as you might have guessed, career trajectory and perspective, kind of skill development, and future-looking, sort of crystal ball, doomsday, if you will, questions, and we'll pose those to the panel as we go on. But please, let's start. We'll just run down linearly, and we have 3 mics to share, so please pass them back and forth as we go.
Okay, I think this is working. I'm Grant Rotzkoff. I'm coming from Stanford. I'm in the chemistry department there in the Institute for Computational and Mathematical Engineering.
Hi, I'm Simon Kornbluth. I am a research scientist at Google DeepMind.
Katie Malone. I work at Tempus Precision Oncology. My background is in physics.
And I'm Bob Montgomery. I also work at Tempus. I'm a director of data science there, and I oversee 3 of our imaging data science groups.
Hi, I'm Kritika Manohar. I'm an assistant professor of mechanical engineering at University of Washington. My background's in applied math.
Hi, I'm Kohit Ishkar. I'm an assistant professor in biology and also in ECS, York University, Toronto.
Okay, wonderful. Let's welcome all the panel. And so I'm going to kind of maybe even hinted a little bit at how I think I'm going to go through some of these questions. And of course, they can and should evolve as we go. The audience, all of you should feel free to pepper the panelists with additional questions, but we'll kind of kick it off with some of the crowdsourced versions. And I'm going to start with the sort of skills and then get into actually the bulk of the questions that we prepared were kind of career related. That was a lot of the feedback that we got. And hopefully I'll try to manage it so that we end with, the doom and gloom questions towards the end. Okay, so several people asked sort of as hinted, what sort of skill development do each of you feel has been impactful, and questions associated with, machine learning scientists, both sort of looking at academic trajectories, and that will bring us, of course, into career development later, as well as industry-related applications, and then also just kind of looking back from your perspective that you're in now, what skills might you have wished you had developed or spent more time doing? So I'm going to do this quasi-randomly, although of course humans are terrible at being random number generators. But why don't we start with Kritika?
What is the first?
So basically, I can just pose it very clearly. What skills do you think are the most important for machine learning scientists and engineers to develop? And what would your advice be for early career researchers to focus on in terms of that development?
So in addition to the standard skills in, computer science, some kind of fluency in the computational methods that are used for machine learning and AI, I would say also, in my experience, collaborating with engineers and physicists and all sorts of scientists, there's always been a domain of expertise that had to be combined with these methods so that we are essentially reasonably balancing the AI models, and some of them are characteristically black box. So how do you combine domain constraints, safety, trust in models, uncertainty quantification into these methods as is relevant to your field. So this is one of the major questions that that come up when in all of these collaborations. What does your data look like? So I would say for early career, a lot of you specialize in different domains, the sciences, biology, physics, chemistry. And I would say try to get some fluency in the methods that are already being used in these fields. And you will see that there already are some, and there is some terminology gaps between how you may think of a method and how other AI machine learning scientists may think of a method. I think that was evidenced well in this previous talk. So I guess that would be my first piece of advice.
No, that's great. And actually, since we have kind of a decent balance between sort of current academics and current industry professionals on the panel, maybe we could also get one of our current industry professionals to weigh in, and in particular, if you have any complementary perspective.
Yeah, I was, as you were saying that, I was thinking that in industry, it's also a valuable skill to be able to digest information from a much wider perspective than what you might have been trained to do academically, both because there are interesting discoveries going on in a variety of different fields that might have applicability, like large language models, obviously the big topic of the recent months, have applications with, dealing with language and whatnot, but then there are interesting applications that we're kind of looking at in medical imaging, for example, where maybe you could give an image to a model and produce a pathologist's report. So an image to text kind of application. So being able to navigate the information landscape, whereas in academia, particularly in your training phase, you go deep, right? But there's also an advantage to be able to go wide to a certain level of depth to understand what applications might be germane to the work that you're doing. And also because in industry, often you're having to work in different domains as like business objectives change, or maybe you make a career change. And so having familiarity with and being able to digest the information from a wider variety of fields, I think is a key thing that sort of dovetails with that.
No, thank you very much. And I was wondering if maybe, even though we just heard a lot from you, Simon, if, in particular, because of your, the transition that you've made, if you could talk about skills that maybe looking back on, grad school or what have you, you might think of as, oh, I wish I maybe had spent a little bit more time developing that particular skill set. Obviously, this is very personal, but maybe even generalizing that retrospective perspective.
Yeah, I mean, I think like, so I think like I was very lucky that like in my grad school career, I spent like too much time doing software engineering, like more time than I was supposed to be doing, like working on open source projects, and like that was not useful for my PhD, but did end up being useful when I went to industry. I do wish like I
don't listen to your advisor. Is this the message that I'm getting? Because I hope none of my students are in the audience. Okay.
Yeah, I mean, do listen to your advisor, but also like you should have like your own personal interests that like you nurture in addition to like pursuing the work that's associated with your PhD. Okay. I think like beyond that, like probably more mathematical background never hurts. Like I think I had like a pretty good mathematical background coming out of undergraduate, but then like in my PhD, I didn't necessarily use it that much. And maybe if I had found more opportunities to use the mathematical background, I would like be able to do more today.
Yeah, for example, I had no idea I would need to know group theory so much outside of just theoretical physics. Okay, do any of the other panelists who I didn't sort of single out yet want to weigh in on this? Please. Yeah, great.
Just to echo that last point, I think, Bayesian statistics and linear algebra are really important for machine learning, and they're often things that you're taught in a really dry way. But learning the content of those actually quite interesting and powerful subjects is a really useful thing. I was a math major here at U Chicago, and I think this has changed over time, but at the time they were too
Nothing
pretentious.
changes at U
Yeah.
Chicago.
Yeah, okay. So they were too pretentious to even teach linear algebra as a course. So I never had a formal course. I got it through a summer REU. That was their suggestion that we might want to learn linear algebra, but it was viewed sort of as an applied topic. And in fact, it sort of is, but I mean, it's a very, very useful and very deep subject. And there's a ton of things that you can leverage in a powerful way in machine learning, as Simon's talk illustrated. So I would say, you know, if you're looking for like specific things to study, those would be my two suggestions: Bayesian and linear algebra.
Katie, as a physicist who's now an industry professional, any insights?
I'm gonna take the flip side maybe of what Bob said here. He was talking about kind of gathering information broadly and distilling it. There's a skill I use a lot as well, which is like sort of communication back out. Most of the people that I interact with on a day-to-day basis are not sort of as deep in the technical problems as I am. I still need to be able to communicate with them about what I'm working on. And I think there's a flavor of that too that I'll emphasize, which is I spend a surprising amount of time trying to figure out what the problem is that we should be solving. And at least for me, I'm far enough along in my career at this point, like, unfortunately, that then as soon as we define the problem, it usually gets like handed off to someone else to solve, which is kind of the fun part in some ways. But that was something that actually takes a surprising amount of skill to develop sometimes. And that, again, academia may or may not, you know, sort of train you to think about in a way that transfers to industry, which is just like, what is the problem that's going to be valuable to solve, and making sure that as quickly as you can, you're sort of pivoting towards that. And sometimes it's a technical problem, sometimes it's a methodological problem, but a lot of times it's not. And there's sort of an artistry in then figuring out how to maneuver in those sort of situations.
It's wonderful. I feel like a lot of people have kind of emphasized this sort of push-pull relationship between generalization and specialization and focusing, and actually having some sort of perspective that allows you to switch between those sounds like it's quite useful. So maybe actually some of your comments, Katie, dovetail well into some of the career questions that people posed and that we sort of inferred from the input. So maybe especially since you've got an academic perspective, one of the questions was, how does one make the most out of their PhD career-wise when mixing both AI and a particular field of scientific expertise? For example, here was computational biology, but not too far from your field. So what do you think about that, and how to sort of leverage that in terms of publications in various, you know, either sort of technical domains or scientific domains?
So I worked during my PhD in neuroscience and also during my postdoc in neuroscience. And currently, like, neuroscience is not like unique in some sense, but most scientific fields, like, there is a huge demand for using AI to solve certain problems. And you can, like, you know, I don't think you have to think much for many disciplines to figure out where AI and machine learning broadly can be used. So I think, like, to balance it, I actually don't think you need to balance AI. Like, these are not separate things. Like, for example, you can use it, for example, like, you can use ChatGPT to do a lot of stuff, like to do literature search, or to even, you know, like, get help writing or thinking even, like, so. And it's just the beginning, like, right now. So the whatever version, like version 4 is out there. So I think like even learning how to even use those tools, even if you're not using it for coding and things like that, which of course, like, ChatGPT is very useful for coding as well. So I think there is one level of interaction like that, which I don't think is any balancing act. There has to be a tab of ChatGPT or something like that open all the time, according to me. The other part is actually, like, for me is, like, you know, I think it might resonate with some of the points being made. I think most of the times in this age where there's a lot of tools out there. So if I go to a summer school, like we organized one at Woods Hole, like from day one, there's a lot of emphasis on, oh, there's reinforcement learning and you can do this and that, and there's this other technique and this other technique. We kind of lose track of, like, what are these techniques actually useful for? So kind of like, yeah, we're roaming around with a big hammer, but we don't know where the nail is. So I think sometimes, like, you know, that might be the balancing act to actually realize like what are the problems and which tool is good for what problem. And I think that, yeah. And again, I'm kind of like still starting my career, so I am also kind of learning from the panel as we're going. But this would be my
I'm
this would be
certain,
my
yeah.
2 cents.
No, thanks a lot, Ko. Another part of that question was sort of what kinds of activities or efforts, networking, internships, et cetera, might be helpful in order to, as posed, kind of get the most out of, let's say, a PhD stage, or I'm sure this also applies to some extent at a postgraduate, post-PhD stage. So I was wondering if we could get Bob or Katie to weigh in on this from another industry perspective, and then maybe come back to Grant for another sort of academic perspective on it.
Yeah, so I'm actually a huge advocate for internships. Those are not super common in the field of physics that I come from, but I did one anyway because Sudong didn't tell me I couldn't.
We had the same advisor.
We were in the same
at
lab,
Stanford.
yeah.
And just full disclosure, I did not invite Katie to this. This was
No.
entirely independent of me, so it was great to see her again.
Yes, it's good to see you too, David. Yeah, so that was a little bit of me going outside of maybe the classic swim lane. And I recognize that not everyone sort of has that opportunity or an advisor that's cool with that. But it really worked well for me. It worked well for me in a couple of ways. Number one, some of the relationships that I made there helped me figure out then what job I would be like most successful in when I actually graduated a year later and went and found my job. Like basically there were some like friends of friends that were working at the company that I ended up getting my first full-time role at. So there's sort of just that like network effect in your, the first job is kind of classically the hardest one to get. So that kind of lowers that barrier to entry. And at least for me, like deciding to leave academia was something that I was reasonably certain about, but it gave me a test run and made me feel more confident in that decision. And I got a chance to kind of see in particular, like what working at a startup was like. And I think I was much more comfortable with a broader range of roles than when I went out onto the market. So I'm a huge advocate of this for folks who know they want to leave academia or even just think they want to leave academia, want to get a little bit more breadth of experience. It worked out really well for me. And there are a lot of good options there. Again, I say that this understanding that may not be an option for everyone, but if you have one, I'm a big advocate of that. Also, Tempest does summer internships, so hit us up.
And Grant, please.
I mean, I would recommend it even if you're not considering leaving academia. So I did my postdoc at NYU, and there's a very strong pipeline at NYU to FAIR, which is now fundamental AI research, but was called Facebook AI research. And there's still right now a kind of computation gap between what industry is capable of and what the sciences are capable of. And that leads to industry asking sort of different theoretical questions within their own research labs than what are typically asked in academic labs. And, I think there's a lot of synergy that we can exploit by using the sort of, wealth of these companies, right, to ask interesting questions. And so there's definitely a strong connection between the two. And so I think that's something that, can be really useful both to ask important academic questions, but also, to create sort of skill development for individual students. Like I have a student right now who's doing an internship at Amazon, and, he's learning, really how to code at a professional level for large scale deployment of these models, which is something that I have a little bit of experience in, but it's not something that I could teach him at the level he'll get now. Yeah, and so to kind of circle back to the initial question about, which sorts of problems should you work on, I would say that, I think one of the things about industry work that's kind of nice is that they have a very careful design of the problems that they choose to work on a lot of the time, and probably not always, but in applying machine learning to, problems in, for example, biophysics or other topical scientific discipline, I think the central thing that we should all be seeking to do is identify the questions where machine learning is going to have a real impact that, expands the capabilities of scientific research, rather than just using machine learning to use it. I mean, we've had, about a decade now of sort of proof of principle type papers, right? Machine learning for X. And, I think we're sort of reaching the level of maturity now where we can look at a problem and try to assess whether or not machine learning is really going to be a beneficial element of, a data analysis pipeline, for example. And so I would encourage all of you, if you're thinking about using machine learning in some aspect of your research, to really try to, use it to solve a big problem, a problem that you couldn't solve in another way.
No, thank you. So I have a couple of questions that I'm going to pose to a few people specifically, but I wanted to pause. Yeah, exactly. To take some questions from the audience. Yeah, exactly. Thank you, Aaron.
I have the sense that many of the internships are really set up for graduate students, right? Many postdocs actually want to transition to industry. And I was wondering if any of the panel, particularly those in industry, kind of comment on, I guess, whether that perception is true, and then if you are already at postdoc stage, how fast to pursue that transition?
Yeah, so in the past, like there were major AI labs that had these sort of residency programs where you could get hired after your PhD. I know at Google, our residency program no longer exists, but there may still be other opportunities like that that are available for people who already have a PhD, maybe have already done a postdoc, who want to try doing some ML in an industry setting.
I can just quickly comment specifically. I know of at least one firm, Sandbox AQ, that is actively building up their residency program at the postdoctoral level and PhD student level. Any other comments on that question or more questions from the audience? I just wanted to take a pause. We've been running through some of the questions pretty quickly, so please, yes.
Journey and is looking to go to grad school.
Yes, Kritika.
So one piece of concrete advice I have received and my students have received from one of our advisory board members at our AI Institute back home is don't cultivate skills or train for a specific interview or job. And that's pretty common in Seattle. People say they want to land a job at Amazon, Google, and so on. The advice is to cultivate a set of skills. So whether that is computational or in your domain, and also, I guess this applies to a lot of fields, cultivate a portfolio. So if you are working on code and you have experience in software carpentry, which is a valuable skill across many domains, that is particularly valuable. In fact, to address one of the previous topics, like what are some of the opportunities for postdocs, I would also, if you're interested, look into the national labs. My Idaho National Lab collaborators actually maintain open source code for their reduced order model suite. And that is very impeccably maintained. So software carpentry is something that you wouldn't think would be required for working at a nuclear lab, but it apparently is in this day and age.
Just to add to that, as a question, I can't imagine that, the skills and the portfolio that you're developing, that you're suggesting one develop, especially if it comes along with a strong sense of sort of engagement and excitement, that's going to spill over, I would think, into, then your sharing of those skills and, successes in your portfolio, whether it's a job interview or admissions application.
Yeah, it's definitely a very transferable skill. You can apply to jobs throughout industry and also cultivate, your own, set of papers, whatever you have that can go in a portfolio, put it online, advertise yourself. And you never know what kind of networking opportunities that might open up.
Come to summer schools. Other perspectives on that? Take maybe one more. Yeah.
Yeah, maybe I got your question wrong. Were you asking whether if you're trying to go to grad school from like bachelor's or something, is that what you're asking? Like what would be like, maybe one other not maybe non like kind of portfolio style preparation that you can take is like one suggestion that I got, which kind of helped out, is that don't look for one supervisor. And usually many times like labs and others are having multiple supervisors, and usually they could be from two slightly different disciplines. And one thing that helped me also with setting perspective of like whatever I find interesting today might be completely different like few years later on. So I tend not to commit, or I tell at least my students to not to commit to like this is it and this is what I will be doing. So whatever they get interested, pursue it for a while, but with the idea that you're going to develop broader skills and not just like one specific thing.
I would emphasize that comment. Oh, yes, please.
It was previously mentioned that the questions that may be asked in private industries, especially in the AI space, may be slightly different from the ones that are asked in academic context. And I'm curious from my perspective, this is something that is very unique to the AI space, especially compared to other disciplines. And I'm curious how you think that benefits the overall research progress that is being made in the space, like the diversity from industry and academia and the different types of questions that are being asked and how that is beneficial to the overall research.
Yeah, so I think one thing that we say sometimes at work that I'll speak to a little bit that maybe speaks to this, that we have a saying that we sometimes use, which is like, you should, in academia, it's really, or in industry, it's really important to like own the problem instead of the solution. And what I mean by that is, like, for example, I work in clinical trials, and there are elements of this that are very data science centric and where I get to code. And there are a lot of elements that are fundamentally not. They might have to do with like just record keeping, or like, you know, where the personnel out in the field, or like there's this salesperson who like doesn't get it, like all kinds of stuff. And there's, you know, there's some, as I'm navigating that and as I'm working with other, you know, people who are working with that, like one of the failure modes that sometimes folks can have, especially like earlier in their careers, they're like still learning the landscape of the problems, is to, you know, kind of block out everything that isn't like coding a machine learning algorithm. And I think this is something that you like develop more of an appreciation for with time, and you get kind of an intuition for what the business values, in addition to what's sort of like scientifically interesting, or what you think might like make the world a better place, which unfortunately is not always exactly the same thing as what your company is doing. Like if it is, this is one of the reasons I like working at Tempest, is because there's like high alignment between those two things. But you know, that's one of the realities of industry is, you know, they're not always perfectly aligned. So I think when we think about, you know, the interplay between academic, you know, maybe methodological development and industry, you know, a lot of the nuance of that is like knowing on the industry side, what is a machine learning problem, and like, how do you formulate that exactly? And then nestling that in properly with all the stuff around it that isn't a machine learning problem, which is, you know, can be, it sometimes feels like some of these problems, you have like a little nuclear payload of machine learning, and then like a giant rocket of like other stuff that's built around it. And it's really easy to get like excited about the payload, and if you lose sight of the rest of the rocket, like it's not going to go anywhere.
Come back to the morbid questions later, Katie. Thank you. It sounds a lot like the suggestion to develop, maintain, and grow perspective that I think we've heard from a lot of people. Yes, please. Unless, was there another comment? Simon, you almost looked like you wanted to respond to that too, but.
Yeah, I mean, I can, so I think like actually like in the pure ML research space, like at least to date, there hasn't been a huge difference in the kind of problems that like people outside academia have been trying to tackle, and people in industry have generally like been trying to build the same kinds of systems as people in academia. People in industry have had the advantage of having way more compute, and so we managed to build better systems. I don't actually know what the future is going to be. So like, I think there's some potential that you can still do foundational work about like what kinds of architectures should we be building at a much smaller scale than what people in industry are doing and contribute there. But I think there's also some possibility that it's going to turn out that you just can't do that because like a lot of the details of these systems are secret, and without knowing the details, you won't be able to build on it. I'm hopeful that that's not going to be the case. But like, yeah, I mean, so far I feel like actually like in the pure ML space, the main difference is scale, and there's some stuff that can only be done at scale, and that's coming from industry. But like overall, the same questions are interesting to everyone.
So there are two questions at least that I want to get to, but we had a few more from the audience. So let's take those, and then I'm gonna move the panel along. Yes, please. Oh, yeah.
I am a PhD student at physics. So what I want to advise is when applying for a graduate school, just be brave. Don't worry about like what's the future, like what skills would I need? Like will I get easily employed if I enter this program? Just be brave because you are still young and there are overwhelming choices. So the cost it's always a fortune to like a wealth to like eliminate one of the choices, even if you get something that you don't like in the future. Because you are still young, and that's the biggest wealth. That's great.
Amen. Okay, so there was a question that I think a lot of people probably have an interest in, and I think we'll do sort of one, again, kind of academic perspective and maybe one more industry perspective. And that's your personal journey in the AI field. Was it a linear path, or were there unexpected turns? And how did your expectations during school match your current role? So Bob, do you want to?
Sure. Because I'm going to imagine my path is taking the most twists and turns. So I'll invert that a little bit. Like, did I end up, working in like my career? Did any part of my career match what my expectations were when I went to graduate school? No. Like a lot of people, I thought I wanted to. Yeah. So I'm an economist by training. I was getting my PhD. Very early on, I realized that like the econometrics was the most interesting thing to me, which was not even what I expected going in. I thought of myself as more of a micro theory kind of person, and I did some of that. But by the time I got out of graduate school, I didn't want to go into academia for a variety of reasons. My piece of advice would be, when it comes time to put your committee together, think hard about it. I'm not going to go into why I have that advice, but anyway, what I did emerge from my graduate program with were two primary skill domains. One was just being able to work with data. I was working as a research assistant, building econometric models with real world data. And, to some extent I'm more of a manager now than a practitioner, but that's what I've spent a lot of my career doing. The other thing was I just happened to be fortunate that I worked at a computer lab and then became a Unix system administrator, like half-time, to support myself instead of continuing to work a TA ship or an RA ship. So who knew? But later on, when Linux became the predominant platform for a lot of these things, I already knew like how to do everything. But when I came out of graduate school, I actually worked for the first almost 20 years of my career in contract research, primarily in survey research, actually, as a statistician or a statistical analyst early on. But even in that capacity, I was always doing stuff like I would work on big telephone surveys, and we're trying to figure out how to make them more operationally efficient. I treat it as an applied data science problem, like what's the probability given the contact history with a particular phone number that the person will answer on the next dial, and how do we use that information to improve our operations? So when data science became a thing, I changed my title to data scientist and was principal data scientist at NORC, which some of you may have seen. They have offices here. I didn't work, I worked in the Loop, but after a certain period of time, so not doing any economics, having the title of a statistician, even though I don't have a degree in statistics, becoming a data scientist, and then really wanting to get fully into the deeper, more complex aspects of data science, I left to go to the startup world. I joined Uptake, which is a Chicago technology company, worked there for a year. And then 3 years ago, I joined Tempus, which is they're in the same building. So I moved from one floor to another. But and subsequently, I've been working in, healthcare in the medical precision medicine field. So the thing that got me through all those things were the fundamental skills I learned in my PhD program, particularly I have to say, working as a research assistant for a professor who was doing research, building econometric models, learning how to program in SAS, learning my way around Unix at the time, how to work with data, what does clean data look like, what is bad data, which model should we be fitting to this? Those skills go all the way through your career working in applied analysis and in machine learning. And the other thing was, some of the same things we've been talking about, how to frame a problem, what's the right approach, what do you have to think about in order to solve it? Not just, hey, I saw a cool paper about this and such, let's try that, that's fun, you should do that in your spare time, but, when you have a practical problem to solve, sometimes you need to make a decision and go with it. And that's how I ended up being in data science.
Wonderful, thank you. And maybe Krithika, could you comment on the path to tenure track faculty? And how linear it always is.
It wasn't very linear. So my undergraduate degrees were in math and computer science. And towards the end of my degree, I did do an internship at a computer firm, basically. And I was debating whether I did not enjoy that particular internship. And one thing I did not enjoy was abandoning a project that I had worked on just because, for reasons. So I decided to go into graduate school, and I had a choice to make between computer science and math and applied math. I chose applied math because it seemed like a compromise between the other two. Sorry, I might be saying totally controversial things. And then I did a postdoc in Caltech and decided to, someone in my network reached out and said there was an opening in mechanical engineering and we need more computational, fluids people and so on. And it was 6 months after I graduated with my PhD. So I ended up putting in maybe just a handful of applications just to, balance it out. And it ended up working out, and I ended up deferring my starting position until I can finish my postdoc, essentially. So I don't know if that's linear or not, but I guess the fields that I was trained in, applied math and computer science, lend themselves really well to research in AI and machine learning. I also consider myself a methods person, which means that I don't like to specialize in any one particular domain. And that has enabled me to work on a lot of really interesting problems, basically whichever I find interesting at the moment. Before undergrad, I also dropped out of art school. So I guess that was the most nonlinear part of this trajectory. So always, I guess, revisit your interests, go towards what you enjoy doing, what basically gives you joy in, take a lot of subjects in many different courses across many different departments until you converge. And you may not converge. I may be doing something entirely different in I guess a decade or so is the time scale.
Wonderful message. Okay, so there are clearly a bunch of questions I'd love to ask. We're coming up on time, and I think that there's something that is generally on people's minds when we talk about AI and machine learning, and that's ethical, moral, social implications. And we had a couple of questions on that. I'll probably just focus on one version of it, and that's how we might be approaching, the use and development of these sorts of tools responsibly, and what are, again, get as doomsday as you'd like, some potential implications of destructive outcomes, and how we, maybe by way of a case study, how we avoid them, etc. And so as purveyor of clearly the most destructive possible outcomes, let's start with Google. So Simon, I'm of course kidding. Somewhat. If you'd like to go ahead and start, that'd be great.
Yeah. I mean, I do think there is like real potential for real damage to the world from the stuff that we're developing, and we do actually need to think very carefully about it. I think there's also like there's a lot of potential for good things that come out of AI. Like presumably that's why all of you are here in the room, because you think you can do good things for the world with AI. I think like we definitely need a regulatory apparatus going forward to figure out how to build things safely. I think we need to be careful about how we do that. We probably don't want we don't want to concentrate power in the hands of people who have the compute, because I think that will be bad for society. I'm not really sure at this point what the major risks are going to be. What I'm most concerned about is like we are going to be developing new technology potentially faster than we ever have in the past, and like we want to make sure that when this technology goes out into the world, it's going out into a world that is prepared for it.
Okay. Yes, please.
This maybe is like a little bit of a counterpoint, but not necessarily. But I think actually the biggest current risks with AI systems in general is deployment without understanding. So as we increasingly integrate machine learning into various sorts of predictive tasks, or self-driving cars or things like that, that we lose an element of predictability. We don't have good error metrics. I think from the academic perspective, one of the things that we really need to better understand is how to make rigorous predictions of errors, of outliers, of potential failures. I'm much less concerned about GPTs taking over the world or something like that. I don't think that there's a plausible mechanism for that to happen yet, but definitely the number of systems into which these sort of unpredictable and unconstrained components are being just put in without really a careful understanding of what they might do. If we give it, a bad random seed, like what could potentially happen, or security issues like adversarial attacks. I mean, these things are still very, very poorly understood from the academic perspective. And I think there's a lot of room to kind of improve our assessment of the models. But so I don't know. I mean, I'm not working in an area where a regulatory component would really be necessary. But yeah, I think that's kind of the core problem to me.
Yeah, so Simon and I are kind of working in similar problem of model interpretability, and so, but I might want to make a slightly different point. So I think many times when we think of AI ethics, many of us are thinking of like Terminators and like the end of the world. But I think already there are like basic problems that needs regulation, and sometimes like it is easy to dismiss an effort of like building a regulatory body if you only think about like these doomsday problems, and there are like this day-to-day problems that are probably there already with current AI that needs regulatory body. Like whenever like 8 people out of 9 in the lab is working with AI models and doing something specific, changing their models to like control behavior or things like that, to me, it automatically requires some kind of regulatory body to be there. And currently in most universities, like I've been to Rutgers for my PhD, I've been to MIT for my postdoc, I'm now at York, there's none. Like if you want to do animal research, There's a lot of regulations that you have to go through. You have to write your protocol, blah, blah. Human research, same thing. But if you want to run anything on code, forget about like what kind of code you're running. You're just using up a lot of energy, and who's accountable for that? Like you might be doing complete nonsense for a long time, but running them on like thousands of GPUs, taking up high performance clusters. So I think at least from these even very like, rudimentary things, we need at least to form, like I have never found, like humans like to come together and talk, many of them come together and talk and like discuss stuff. So I think we should start forming ethics
What
bodies
gives you that idea?
locally. Exactly. So
Sorry.
no, form bodies. I think like form like regulatory bodies and ethics committees, I think is important for any computational work.
Yes, please. I mean, I think this is a question we'll probably end on, so we have a couple minutes to hear from the rest of the panel.
I want to somewhat dovetail with that to say that, so the industry we work in is a highly regulated space. There's all sorts of privacy regulations and HIPAA and all that.
Healthcare,
Healthcare,
medicine.
yes, healthcare and medicine. I think that AI should be in, sort of like what are the concerns, should be part of a broader sort of framework for understanding risks in science more broadly. The pace of innovation is really what makes AI unique. I don't think it's so much that a Terminator-like scenario is likely to come. We've dealt with those sort of existential risks before, and I think we responded with strong sort of regulation and mostly just transparency and understanding of establishing basic rules. I think those are the things that are kind of needed. For us, we already have to fit this into a tightly regulated kind of space. Like if you want to put out a machine learning algorithm in some clinical setting, that's software as a medical device, and the FDA has a whole regulatory policy around it. I think that model could be followed for similar kinds of things, not necessarily with as strict controls for just something that says like, hey, you watch this movie, you might want to watch this movie. We don't need to go through FDA submission to do that. But I think there are models of governance of these things that can be extended to AI.
Katie?
The only thing I was going to echo a lot of stuff that Bob beat me to. The one thing I'll say to a group like this, especially as you're thinking about career paths, is that, the technical expertise to understand what these models are doing and, to some extent think creatively about what they could do. That is, I think, hard to get into government and regulatory and policy bodies. So like, we are all in academia and industry, and it's, at least for me, like hard for me to imagine going and working, in the government somewhere in the FDA, but at the same time, like that's actually probably something that society really needs. So I just want to mention it, if one or two of you walk out of the room today and you're like, maybe I want to be the cops instead of the robbers or something. I think that's a good outcome here. Because I would not overestimate the sophistication of, the current, folks like there are many smart people who are working at, the FDA and any other regulatory body that we could form. Don't get me wrong. But I think it's really easy to, especially when you're like looking for your first job or something like that, to over index on like, chasing the money or chasing the glamour of like working in industry or academia. And there's actually a lot of very important work and a lot of need for like high octane brain power in these regulatory bodies. And, if folks like you or us don't do it, then like no one will. So let me just, give that as a plug.
Yeah, and many of the professional societies have actually science policy fellows, science policy fellowship opportunities in DC. I have many friends and colleagues who've taken those up. Krithika, do you want to end us with your perspective on the ethics? I think we're just about out of time, but we get the whole panel's perspective on this question.
I think a lot of the discussion also depends not only on the type of AI or ML method, but also the data, like as has been mentioned. In engineering systems, these are systems that are already regulated, which is why there's such a premium on having models that are interpretable. And therefore, engineers and people who work on deployment, testing, pilots can actually trust it. And there have been numerous examples of this. So I guess to conclude, I would say when you're training your AI ML model, give deep consideration and be transparent about how many samples, what is the sample population, what is the distribution of your data. I mean, there are fields of machine learning looking into this from a scientific standpoint as well, like active learning, differential privacy, other concerns dealing with the data. And to a big extent, that also separates the kinds of problems industry and academics can work on. So I guess I'll end on that note.
Thank you so much. Let's thank the panel again.